For thousands of years, nails were pretty much the only metal fasteners used to attach two things together. In a previous video, we discussed how nail technology evolved over time and why old-fashioned nails may actually work better than our modern wire nails. I'll link to that video below so you can check it out. I think you'll find it really interesting. But since that video was released, a lot of folks have asked me why we use nails at all anymore, since we can just use screws. That's another interesting question, and my answer may surprise you. So in this video, we'll talk about the fascinating history of screw technology and why they aren't always the best choice. Screws as fasteners to hold things together were not used until about the 15th century because it was simply too expensive to produce a bunch of little screw fasteners in any real quantity. Military necessity seems to be what changed that, since some of the earliest examples of screw fasteners are found in things like suits of armor and firearms. Like the weapons themselves, the screws were laboriously made by hand. The threads had to be cut individually with a file. These very early screws can be identified by their irregular threads. Each one was unique. That means they weren't interchangeable. If you drove a hand-filed screw into a piece of wood, the threads would cut the opposite pattern inside the hole. So if you removed that screw to make, say, a repair, and you lost it, you could not put a different screw in the same hole because another screw would have its own unique shape and thread pattern, and it would destroy the inside of the hole. This made screws very valuable and very expensive. But they were also becoming more necessary, particularly in furniture making, as metal hardware became more common. Securely attaching a drawer pull, for example, with nails, may require a process called clenching, where you drive the nail through the front, and then on the back, you bend the nail over like a staple. This would keep the nail from pulling out, and it might be cosmetically acceptable if you never look inside the drawer. But what about other hardware, such as locks that have to be attached from the inside? You don't want the nail end poking out the outside of the drawer face. Screws solved these and other furniture making problems, especially after the development of lathes in the 1760s, which could make them with evenly spaced and consistently shaped threads. It was still a relatively slow and costly process, but for the first time, screws became consistent in size and interchangeable and more widely available. These early lathe-turned screws can sometimes be identified by the off-center or irregular slots in their heads, which in many cases were still cut by hand with a chisel or a saw, sometimes even by the woodworker himself, who would have to take them back to a shop and cut his own slots. At that point, virtually all screws featured straight, untapered shafts and blunt ends. It wasn't until the late 1840s that new screw-making machines began producing both tapered shafts and pointed ends, and it was perhaps as late as 1856 before consistently centered machine-cut slots became common. These and other changes to screw technology over the years can help experts determine the age of some furniture, sometimes even narrowing it down to just a few years. After the Civil War, though, screw technology changed little until folks finally got fed up with the slotted head design. Anyone who has used one knows how easily the driver can slip or cam out and sometimes damage the workpiece itself. In the late 1800s, many alternatives were tried, but none caught on until a Canadian named Robertson perfected a square recess in a screw head. What became known as the Robertson drive was a great improvement that immediately began to take off until Henry Ford failed to secure the terms he wanted for using those screws in his U.S. auto factory, and instead he backed a new design, a star shape that became known as the Phillips head. Phillips head screws took off during World War II, and then they became the standard in America, while Canada continued to favor Robertson heads. Phillips screws do strip and cam out much easier than Robertson heads, but industrial machinery, especially of the time, took advantage of that flaw because it allowed the driver to pop out of the screw head when the screw was fully seated. Still, the search for a better drive continued, and today there are many different styles. I personally prefer Torx head screws, even if they're ugly as butt. As a mechanical fastener, screws have become as common as nails, but the screw has never replaced the nail, and in some applications, the nail is still the superior fastener. The difference is in how they function. Screws cannot be beat for resisting tensile forces that seek to pull two pieces away from each other. But they're generally weaker against shearing forces that prevent two pieces from slipping apart. So if you're hanging something, for example, from a ceiling, a screw is less likely to draw out over time. But if you're nailing something to a wall, a screw may be more likely to shear off under excessive weight. That's because screws are made from a much harder and more brittle steel than nails are. You can break many screws fairly easily when you bend them over. A nail, on the other hand, will bend many times without breaking. This is a critical difference, especially in construction applications. Houses are typically framed with nails, not only because they're less expensive than screws, but because houses move and settle over time, and nails can bend as needed while screws cannot. That said, some modern construction screws are specifically designed for structural uses, but their high cost make them impractical for a lot of general framing. Nails are also valuable in furniture making. For example, you could not glue a molding across the grain on a solid wood panel. Changes in humidity will cause that panel to swell and shrink in width, and over time, either the glue bond will fail or the panel itself might split. But a few small nails will hold the molding in place without restricting that wood movement. And unlike screws, the nail heads may be small enough to hide. Some of the finest pieces of antique furniture, stuff that's lasted for generations, features nails for attaching moldings and other critical parts, including cabinet backs and even drawer bottoms. That doesn't mean you can fill your project with nails. Too many can overly restrict the wood movement. But a few small nails in the right places can create a unique, flexible joint that will stand the test of time. Nowhere is this principle better illustrated than in the traditional 6-board chest, which is typically built with horizontal wood grain on the front and back panels, but vertical wood grain on the side panels. Normally, crossing the grain like this can lead to disaster because boards may swell or shrink in width, but they never grow in length. So the side panel should restrict the movement of the front and the back panels, and in time, they could split apart. But if those panels are connected with some strategically placed nails, they should be able to move just enough due to the flexible nature of the nail itself. Both nails and screws seem like relatively simple fasteners that we take for granted, but they are equally rich in history and technology, and both maintain their place in our modern toolkits. See you next time. Woodworking is about squares. Fences must be square, blades must be square, tables must be adjusted so cuts are made square. Our corners must be square, our edges must be square. Even angles are sometimes laid out with a square. We use double squares and combo squares and tri-squares and T-squares, mini squares and miter squares to combine pieces to make squares. If you need squares to make squares, there are no better squares than these squares, because Bridge City makes neat squares so everything can be square. Visit Bridge City Tools at the link below this video and see for yourself. Wait, don't go yet. If you're new here, please subscribe and remember to ring the bell. I would really appreciate that. Give us a thumbs up, or better yet, leave us a comment. I always read them. And be sure to check out the latest issue of Stumpy Nubs Woodworking Journal. It's always packed with tips, tricks, and tutorials designed to make you a better woodworker.